As a little background, the UI I'm going to show you has a couple of rough edges. It was slated to be rolled out, and then of course we stopped kind of working on it. For the first initial versions of our tool, we kind of relied on our integrations into other people's ticketing systems to push all the data you're going to see in, for their use and their workflow. All right, let's see if this will share out okay. All right. Okay, so for our UI, we'd kind of land in a dashboard, similar concept, I think, to what we're working on with GitLab. And for us, we have this idea of, we're kind of collecting this idea of severity, exploitability, and the vulnerability type. So from this screen, we're going to give an overview of the severities of the vulnerabilities we're finding. We're going to give an indication of kind of the top vulnerabilities that are affecting their project. And then for us, we tend to view our vulnerabilities by endpoint and operation. One of the things that's a little different about how our tool works from Zap is we can actually test multiple endpoints in one scan run. Since we're dealing with APIs, we want to make sure we could support the idea of microservices or more complicated environments that might include an authentication and host versus the actual target implementation host. For this scan, I have a single endpoint, though, an API that's being displayed. For each of the endpoints and operations, we're going to give a breakdown of the different numbers of findings and their severity severities. And then we also have the concept of allowing a user to tag a scan to record things like the feature branch they're developing on. I did not set one for the sample data, but in the case of that's being set, there's a filter for the user to pick a different branch to view. And the default view is going to be to whatever they consider their primary branch of operation. From there, we can drop into a findings section that's going to start giving a list of the currently active findings that they're dealing with, along with some trend history information. We do have the idea of being able to diff two scans together and identify issues that are new and only display issues that are currently being found in the branch that we're viewing. We don't have any logic in here that deals with the concept of merging between branches. We would assume that as a merge operation occurs, you're going to do a CI run of our scanner, and the findings will be updated for the branch that you've merged into. So if you need a holistic view, the primary branch is kind of where you would go to find that. Otherwise, you can look at your targeted feature branch to see what work is currently going on. In terms of how we're displaying this data, obviously we have an impact happening over here. We're kind of tagging things with exploitability, and then this kind of A5, A6 stuff, this kind of maps over to the OWASP top 10. And so this is giving a view pretty quickly to the end user if they're only interested in and have visibility into OWASP top 10, kind of how things are mapping for their scan. And then from here, I can go ahead and pick an individual issue and we can drill into it. So for example, maybe I can look at a SQL injection that's going on, and we'll give them kind of a nice little breakdown of the issue. For our tool, one of the things that we also have a distinction between is the module that's performing the check or the investigation that resulted in the vulnerability. For example, we have like a SQL injection module that's going to go and prepare different tests to do against the endpoint that will result in one of these issues being found. And that gets paired with different ways of detecting that the issue has occurred. And we kind of, the lingo we use is we have the check is the logic that creates the test case for like a SQL injection. And then an assert is the module that found the issue that basically said, hey, something bad has happened, let's report it. In this case, the detection here, information is coming back from the assert, which is saying that when we did this test case, a 500 error was detected, and that is resulting in us finding this vulnerability. The user has the ability to go into our system and modify and customize how the asserts work. So for example, if I felt that 500 was not indicative of this type of issue, I can go in and disable that in the configuration. For this issue, another assert that might trigger would be a log analysis assertion. So another way to find SQL injection is we could monitor a log and detect that, in which case this detection language would change along with the assert that's listed there. In the description, we also inline the thing that was changed, and we'll list our idea of what the parameter that's being modified, its original value, and its new value. This is something that can be pulled out of the description. This is just where we chose to display that information, but it is available. The other thing that's a little different, that's a different piece of information we're displaying from, I think, the other scanners, is we have a concept of being able to integrate into a unit test framework. In fact, for this scan test, I've integrated into a Python testing framework. And so one of the things that I'm reporting here is going to be the test case in the unit test framework that we used as the base data for doing this test. And so it's an extra piece of information that can allow the user to understand, why we generated these packets, where these requests are coming from, and support their investigation. We also have mappings, as I previously mentioned, to OWASP. We also map out to CWE, and so we'll include links off to informationals for those sites.
Hey, Mike.
Yeah.
Are those the only things that you'll identify, or does this include some of the more, I don't know what you call it, like the just the real parameter fuzzing where you're just trying to throw junk at it to see what blows up?
Yes. Yeah, so along with some of these more DAST type scan modules, we also have several modules that do actual fuzz testing and generate that random data, where what we're looking for is not necessarily linked back to a specific type of vulnerability.
Great. So I was curious, do you provide a severity with those as well, or is that more a true finding in the sense that the user has to figure out exactly what it is and what the implications are?
Yeah, for the fuzzing, we leave it up to the user. And we kind of have, I forget what the default for that is, but yeah, essentially it's left up to the user to figure out. Since if our other checks didn't catch it, then it's truly an unknown impact issue.
Okay, great. Would it be fair to say if I see a severity that it is something that could be tied back to an OWASP or a CWE or something deterministic like that?
Yeah, it should be tieable back, exactly. Yeah, so I think for generating the report format that would go into the dashboard, I'm going to do what the other fuzzers are doing, which is setting an unknown severity for those. So I'll try and mimic what it looks like to have a fuzzing result. The other thing we can do is I can also provide a list of the check names of the modules that would result in a fuzzing result versus more of a DAST check, in case that would be interesting. It's something that would be available.
Yeah, it's something to think about for later. Just the feedback we've gotten from some user testing is unknowns people tend to treat as critical because they don't know. It could be a critical, it could be noise. Because of the propensity of fuzzing to generate lots and lots of unknown findings, we may just need to think how we potentially segregate those out in the UI from other unknown test things. Food for thought for later.
There's probably another also discussion on, I do feel that we can probably provide some guidance on how bad something we find through fuzzing is in some cases. I do feel like from past experiences with the users and fuzzing, at some point you have to provide some guidance on which ones we should focus on and which ones we should not. For this system, one of the ways that can be possibly accomplished is by maybe using the assertion, the way we're finding the issue has occurred, could be a guidance on that. For example, if we see interesting things in a log analysis, that could provide us some hints on how to assign interest to it versus is it just a 500 error? Like, did your application code actually exception? Did we see a database or storage error message? and maybe provide some guidance. Yeah, the triaging of fuzzing vulnerabilities is always a challenge to get right.
I have a vested interest in that because that's going to become my problem, I suspect.
Yeah. Well, we should. I definitely have some thoughts to try how to make that a little bit better that we could talk about. So the other thing that we have that we generate is we generate some assets. We generate a Postman collection with the hope that this would be a really quick way for a user to reproduce the issue. And the Postman collection would come up populated with the operation that we decided was the culprit for what was going on. And then we also have a fault archive that would have the raw binary request and response pairs that are associated with this issue. And we also, along those lines, further down here, would include a series of request response pairs that we've kind of sanitized and truncated when needed that allows the user to kind of really quickly see what's going on. You know, if it was me going through a triage process, you know, the first thing I'm going to want to do is I look at one of these is I just want to see the posts that are going on, the HTTP requests and responses. And, you know, an eyeball of that can probably give me a good sense of whether or not I think this is a false positive, a real issue, and maybe also where it should get sent to in terms of the developer that would work on it. So in terms of what we collect, normally for our scans, we can see we have a good request response pair that we've recorded. So we provide a version of the request response pair that just works. That should be what is expected by the end user. For this test case integration, that can actually be the unit test running and succeeding. And so that gives them something that they can compare against to see what they would expect to have happen in this case, creating this resource versus what actually happened, which was getting a 500 message out of the server. And then they can make a judgment call on what to do from there.
How does the recorded request and response differ from the original request that was at the top of that list?
Sure. You know, one thing that would be nice is to point out exactly what's changing in bold. But one of the things that can happen is the user can look at what's happening. So we see that we're changing the parameter first. And up above, we point out that that's form data. And so we know to go look for the first name, which is %27 single tick is what we're changing versus the original one. The other thing that we're injecting is we inject a via header to make sure that if someone can't reuse the scanner against some random site and not have that easily detectable by a WAF signature set. So this is also one area where the data we're collecting differs a fair bit from what's currently in the scan reports, especially around including the concept of a body.
So does that mean the recorded request block there is identical to the original request block at the very top of the list then?
I see. So this is the, in the case of unit tests, what we do is we leverage the logic in the unit test to make sure that we can perform the sequence of operations every time. For example, if it had to go get auth. So this is from the time we ran the unit test and we man in the middle to change it, this is the original request that we then modified the first name of. And so this is the exact request that we're basing this off of. So what we would expect is that all of the parameter, all of the form data and other items are exactly the same between the two requests outside of what our intent was to change.
Okay, got it. Thanks.
All right. And then we also do have, you know, in terms of mapping this to what the current reports are doing, we do have, you know, a difference between the title that has information about the vulnerability in it versus a title that we can generate from kind of the module that's picking up this issue. The way the system is designed is that we have discrete ideas of checks. So a check finds essentially one type of issue. And so we don't have modules that would do several different types of detection overloaded. So generally one check maps to one vulnerability type that we created in the system. The other thing that I'm not sure, let's see if I have an example of this. We do have the concept of a check being able to find multiple vulnerability, like multiple issues in one go, which I believe is not displaying correctly. But we do have, I think the only one that's really using that right now is we have one that will check for CVEs. And in the case that checks for CVEs, we can have kind of in one vulnerability, sub-vulnerabilities off of it that would indicate here's like all the different CVEs we found. I think my plan for the integration though is, since that's duplicated logic from other scan modules, I was just going to disable it and not deal with the fact that there could be sub-vulnerability, kind of like sub-issues on a vulnerability being found. All right, so any questions yet on kind of the vulnerability display that I can address before I move on? Awesome. So
probably not a question. Maybe one thing that'll be interesting for us to dig into more, though. You were talking about your workflow, about how you triage these quickly, and that you look at the recorded request response pair as one of your first things. Maybe that'll be something that, as we build this out, we can emphasize more as part of our interfaces.
Yeah, I think, once we're past maybe the first person to look at it who may not be super technical, once this gets something where you're involving any of the engineering team members, I really do feel strongly that I would want to see the request bodies. That's like the first thing I'm going to do to get intelligence of what's going on. I think from there, the next thing I'd want to see is the code path. And I think a great future feature for mature customers would be being able to have their the target being instrumented in a way that would pull some of that additional information out. But I think from a user experience, anything we can do to create a really fast triage process would be hugely beneficial.
Agreed.
Yeah, and I think the core issue around that, along with the artifacts, the downloading a Postman collection, is how to get that amount of data over to the dashboard. Because right now the only place is to throw it into that JSON document. So this does introduce, I think, the need to have links to additional assets.
Yeah, absolutely. Certainly when we start dealing with the fuzzing, the size of the injections could be, larger than is reasonable to store inside of a report format or anything like that. And that definitely brings up questions on, data size caps and limits, and versus, and how long we would keep those assets. One of the things that would happen in my integrations with issues is, and this might parallel over to the workflow in GitLab, if the user's flow is they're going to take a vulnerability and turn it into an issue, when they turn it into an issue and those files can get attached to it, that might be the point where we say we're going to retain those assets for a little bit longer. And maybe there is still some idea of, for a scan that you're doing, we're going to expire those assets at some point, similar to what we do with the CI job.
Yeah, I like that approach, because then if it's not important, it just expires with that timeout and the user doesn't care, but it's permanent if you've gone through and clicked promote it to an issue because I'm going to actually do something with this.
Yeah, exactly.
I like it.
That's actually very similar to how we've got the flow set up today. Is in the MR, the results are basically ephemeral for that scan for that particular feature branch unless you take an action on it. I change a status, I convert it to an issue, I open an MR against it. So I think that'd be a good paradigm for something like that. We have the vulnerability object, and to me that would make sense to start attaching the asset there. And then the issues in the MRs will link to that. That's a good point.
Mm-hmm. Great. So the other side of the configuration of the UI for this is largely around configuration of the options. So all of the checks, or the majority of the checks in our system, have some level of configuration along with the asserts. And then also, of course, generalize things like the TLS CA cert you're going to put in so we can forge SSL certificates and things of that nature. We are right now able to store that configuration in a YAML file similar to what the other scanners are doing. The downside is, our conversion to YAML, we did not sit down and, intentionally make it user accessible. It's really just a serialization of our configurations, of our configuration options internally. It's not terrible, but it can get a little complex if you have a lot of profiles. So one thing that we support is this concept of creating a profile on top of a configuration that you might use in different situations. So for example, you might have a weekly scan that you expect to take much longer. Maybe you turn on a lot of fuzzing for that and it runs for several days, and you don't run that very often. And surely you wouldn't run that on a feature branch, but it is linked to your project. Versus you might have the concept of maybe you have a very quick cycle scan that goes on feature branches that must pass before you can promote that up the chain. And then maybe there's, on the more of a master branch, there's a more full scan that occurs nightly on that as you verify, merges into that main branch. From the YAML perspective, users can create their own profiles, and then profiles can have a full configuration of, cross my fingers that this all works, can have a full configuration of the different checks and asserts to customize them to what you want that scan profile to be. The start of that is we can do things like turn on and off all of these options, and then we can also drill into them. And so, for example, if I took, maybe SQL injection is a good one to take a look at. So in the SQL injection check, we're going to expose a set of assertions, some of which are configurable, to allow them to customize checks to their code base for doing things like we could turn on a custom assertion that can allow them to put in custom error codes for a JSON response. So in the case that they're returning, their own proprietary error codes, they can put in here and say, hey, if you see this, then that's our database error. You should definitely assert on that. They can go in and configure the log analyzer and the strings it's looking for and the categories that are being used. They can also come in and maybe modify the types of injections that we're doing at kind of a high layer and say things like, well, I don't want to do that, or maybe my database has a couple strings you don't know about that might be interesting to us, and modify those. Because we support testing more than one endpoint at a time, we also allow for this configuration to be specific to an endpoint in a profile in a configuration. The reason for that would be if I have one endpoint in Python Flask and I have another one that's written in Java, the assertion configurations for what a false positive might be or what checks I want to perform on those two sites could be different. So an added complexity to kind of how this all works is at this profile layer, you're going to see that I've tagged this with, there's a route specifier here. And one of the things that the user has the option of doing is also defining different routes and endpoints that we're going to be testing. By default, we kind of have a catch-all, and it just says that whatever you access while we're in the middle of your communication is going to get tested. But it would be common for an end user to have two routes, one maybe for an authentication box that they do not want to test, and then one for things they do want to test. Or if they have different backend systems and they want to customize that, they could have more than one route here. As you add routes, the screens on the profile can get more complicated. And if you were dealing with this in the YAML, it would even be more so. Because suddenly you'll start having an explosion of options that might be listed. We have done some work to only show changes to our default configuration in the YAML. So right now, if you export the YAML configuration, it's not going to show every check, every assertion, and every option. It's going to show the ones the user has enabled. And so it does look a little bit more reasonable in that sense. So in terms of the base layer configuration, we have the idea of having some TLS certificates that they can put in, that they then can trust on their systems to allow us to forge things. We do support the idea of client authentication, client cert authentication, in which case they can embed a set of certs to use and private keys that we would then try if we were prompted to when we're connecting to our target. We have some general timeouts that they can tweak. This can really affect the performance sometimes of the testing that we're doing by how long do we end up waiting for responses from stuff. And, you know, just a bunch of other stuff. This ignored failure screen will go away. In our system, we have the ability to mark something as we're not going to, you know, it's not a finding. We don't want to deal with it. This would simply show our list of all the ones that have disabled or chosen not to address. The reason we have this is, you know, a common thing that we would get asked by a red team or a team that would oversee the engineering group running this tool is they want to know if the engineering team has made any weird choices that they are then like maybe would be in disagreement with. So we have a central screen where they can go and say, here's all the stuff the engineer said they're not going to fix. I just want to make sure I agree with that and then move on.
And just to be clear, this is with the results. So you're ignoring certain results that come back. It's not changing the rules that are
Correct.
being executed.
Yeah, the way we handle that is, you know, we never stop looking for stuff. We just won't report it back into the UI the same way.
Right. So there is the potential for someone to say, hey, I don't want you to find that vulnerability. I'm going to go into the profile and shut off that check.
Yes, the only way to stop finding an issue is to turn the check off. So our second way of doing that is you can disable a finding. Is kind of, we had to have this on and off button in our finding UI right here. And if you click that, we still find the issue. We just don't report it into the UI or to integrations. And since that could be a sneaky way to hide doing work or, you know, making the wrong choice, we want to make sure that we call that to the attention of someone.
Got it. Yeah, I just wanted to highlight this because there's a very subtle difference that we're running into on DAS. It's like you can say, don't run this rule. And then you can also say, run this rule, but hide the results. And so the implication from an auditing perspective is different.
Yeah, and, you know, one of the ways I talk about that is, you know, like we're seeing a bunch of clear text authentication issues here. It's quite likely at some point that, you know, one section of your API may need to be unauthenticated for a mobile app or for whatever reason. And, you know, but you don't want to stop looking for clear text authentication. So an easy way to handle that is we can just say, for this instance of this vulnerability, stop reporting it. And then from this UI, we would list any ignored faults kind of, you know, hidden here so they can always see what they're choosing to ignore. But none of the integrations would end up showing it. It wouldn't show on here, it wouldn't report back in the stats for your dashboard, but it's still kind of getting identified.
When you're ignoring something, what are you ignoring? Is it the combination of the check and the endpoint?
Yeah, exactly. So it's going to be the combination of the check. I don't remember if it includes a cert, and then it's going to be the endpoint and operation. So it'd kind of be like delete on this plus this, and then that's kind of the scoping of it.
Okay.
We're trying to make the on-off thing just really, really targeted to an instance of a vulnerability. We don't believe that this is what you would do if you're finding a lot of false positives. That's a different workflow in our tool. If you're finding a lot of false positives, what you generally would do is you'd come in and modify the assertion configurations. So for example, you know, here I have a lot of SQL injections, and if we were to dig in, a bunch of these are being found because of 500 errors. And so if I felt that that was wrong, like if it was Java, 500 errors are meaningless. You just always are getting them. And so something I can do is I can come into SQL injection, and I have a couple options. I can turn off the status code assertion, or maybe even better, I can come in and say, maybe 500 isn't what I want to look for, but maybe there's some other status codes I can look for, and do things just a little bit differently. You know, or maybe I turn off status codes and just rely on log analysis and maybe a custom body for a custom error message that might come back.
Out of all the different places that users can do configuration between the routes, profiles, and the check configurations, where did they spend the most time in your experience?
So usually what I do is when we onboard a customer, we would spend some time um, doing what I call integration configuration, which is my goal for this tool was to make it so the configuration only changes when you make major changes to your code base and not on kind of a day-to-day. So my pitch to the customers is when you turn the tool on, we're going to spend some time configuring the assertions and the checks to get the timing of the scans to what meets your SLA and to get the results, coming back the right way. And then once that's done, hopefully it's just set it and forget it. So for me, I think the biggest thing you would end up doing is you'd come in and modify some of these assertions. One of the things that I would like to do for the GitLab integration is be smart enough that since we can see their code, it would be great if we can already know, like, hey, for Flask, we should make these changes and try and minimize the configuration they need to do. But most of the configuration is going to be kind of one, getting any integration to work, and then two, going through and making tweaks to the checks and assertions that you're going to do. So I think for the first round of documentation, I am going to try and include a section that says, hey, if you get a whole bunch of false positives, here's 3 things you can just do in the YAML to start, getting a better handle on those. While we work to either having UI around the configuration file or better documentation around that.
Okay, got it. Thanks. Yeah, because especially as you were going through the profile section, I was trying to mentally map like what do these profiles look like versus what we'll have at GitLab, right? Because if you're in your CI pipeline, you'll probably just have one unless you use an environment variable to flip it, or on-demand scans possibly. So yeah, that's just good context to hear that it's mostly the configuration of the checks more so than profiles being a major thing people spend a lot of time with.
Yeah, most people usually, so I guess what my experience with the profiles is, the red team's got, the red team is usually hit the full button, and they're usually doing a one-off scan. And then other than that, I usually start people at quick and nightly and just kind of, slowly ramp them up. I like starting people at the fastest scan so they can see a couple vulnerabilities, get invested in it, and then they don't, because as we go up, I really do turn on some fuzzing, and that just starts taking a lot of time. And so we kind of ramp up their expectations after they see some results, which is nice.
Okay, great.
Are you able to, I think you kind of alluded to this, you can segment it out by the specific endpoints or the routes, but I guess what I would see doing with this is like only run some of the more intense fuzzing on parts of the code that had changed. Like if I detected that what underlied a particular endpoint had been modified or there was a new one added, is that something that it could do today, or is that, I guess, Sam, maybe more a question for your roadmap around this?
Yeah, it's not something we can do today. And the main reason is the system was not designed to have the intelligence of the code and understand the merge request in the branch. So I think those are great ideas. In terms of bringing that to fruition, that idea, one of the things that we also need to understand is a little bit more how the vulnerabilities and things that we're finding map to the code changes. And so we do have some ideas in flight that we're brainstorming on how we could identify, get some code intelligence to say things like, hey, this operation's in this section of the code, or even from our scans, instrumenting the backend target and being able to see the areas of the code we're hitting as we do some of the checks.
And I think eventually, once we're able to use both Peach technology as well as some of the coverage guided fuzzing technology, bringing those together should probably help us dramatically there as well. Since we have an instrumented build in that case, we could probably use the Peach technology to try all the different things in the API spec and see what happens in the actual implementation itself.
All right, I think that was a reasonable overview of the UI. Is there anything I can dig into a little bit more since we have some time, or is there
I'm not sure if
anything
you
you
touched
wanna-
on jobs.
Oh, jobs, sure. You're right. I totally glossed over jobs. Jobs for us is a scan. And so for this case, I've seeded 2 scans today in here. For this view, aside from the normal information you would get about completion and whatnot, this is also where if a scan failed, you'd be able to see an error message from our tool that says, here's what happened. Like we couldn't look up the DNS name of your target endpoint, or something major what happened, like your target disappeared and we can't contact it anymore, would pop up in here. So for the result of a scan, we have pretty much like 3 general states. We have a scan has completed successfully and has vulnerabilities. A scan is completed successfully and does not have any vulnerabilities, and then an error condition.
So this would pretty much map to our GitLab jobs then, with the failures it's finding being the results of the faults, right?
Right. Sounds right.
Yeah, and the failure count, I think, is something that we are now introducing in maybe 13.2 is actually having in the pull down how many issues were found. And then, Mike, is there anything under settings that's worth looking at?
No, I don't think so. Most of this stuff is not going to map over or expose in a different way.
Okay.
These are basically product-wide things. Like for our customers, they have the ability to download support bundles and report that back and and back up their database and things like that.
Perfect. Thanks.
If since we have some time, were we going to go through the Peach sidecar program today as well, or I'd be interested if there's anything that is unique in that application that is part of the web app that we would want to, look at.
I don't think there necessarily is. So I don't know if I have Sidecar installed, but I do have. So basically, we have our kind of anyone's used Insomnia. It's basically a clone of Postman that's open source. And we forked that project and added and kind of made a version for our customers that had our scanning, the ability to start scans built into it. And that was really great for demos to customers and having them do proof of concepts where they didn't have to do anything but import a Postman collection, which most customers have, and then click go, and our tool would start a scan for them. Because it's its own tool, I question the benefit of whether it'd be great to have it or not have it for GitLab. I kind of go back and forth on that.
Yeah, definitely agree, because it seems like a tool you would use primarily for more of an interactive testing workflow as opposed to the CI/CD workflow, which we're really pushing primarily. So would it be a fair summary then that the sidecar is really just an interactive interface to all the same things that you could do with the web interface then? Would that be accurate?
So one of the, it's a little bit different. So I guess the way that our tool works is it usually ends up being a man-in-the-middle proxy. So the thing that you also pair with it is like some sort of runner, something that kicks off the test and provides that input data. And so Sidecar was kind of a graphical way of doing that, where you can basically just say, take whatever's in my operation here and make it and start testing it. And then we could like pull back some initial stats on the test and things like that. So I think its usefulness was more from getting things working and evaluating the tool than something I would expect users to actually make a lot of use out of. Since we really position this as CI integration, what would really happen is, you take your Postman collection and feed it to a tool on the command line that would, kick off your test in your CI pipeline. Normally, we would find that, for red teams, our burp integration could be popular. So we have a plugin for burp that would where you can take your sitemap and just click go, and it would start scanning it, and then populate the results back into the burp UI and things of that nature. What I was really hoping for, and I haven't checked recently, is that Postman would expose a good plugin interface that will allow us to integrate. Really I wanted to integrate directly into Insomnia, but they did not have a plugin interface that was adequate for us to do that.
Mm-hmm.
I've got a quick diagram that might help out. Let me see if I can. So I don't know if everyone's seen this diagram. So you've got the Peach Runner here, and Mike, certainly if there's things that are inaccurate, but let me know. So basically you have Burp Suite, Fiddler, Har, Swagger, all of these can export files, which then can go into the Peach Runner. And we also have a tool called Peach Recorder. So you can send HTTP requests through Peach Recorder, and then Peach Recorder will save out a Har file, and then the Har file can be used as a seed essentially for Peach Runner. So all of these tools, including I would put Sidecar up in this area, are essentially prerequisites if you want for Peach Runner. So they're not part of the core technology, but they do make it easier to get data into Peach Runner.
Got it.
And then, so some of the other stuff that we've got, you've got JUnit test with a Peach library. You've got PyTest with Peach library. So there's some additional elements in the SDK which allow users to run tests much easier.
Mm-hmm. And we also support things like, oh yeah, you have Selenium on there, integrations with Selenium and other technologies. I think my hope with this tool was that, a neat way of doing this for a mature customer was, really driving everything off of their unit tests. Since the unit tests are the most likely to get updated as new features are added and not require, and then remove a lot of the maintenance burden from the user.